Hi everyone, welcome to Go Classes. So in the last lecture, we were discussing addressing modes. Now we will continue. We have already seen some addressing modes like implied addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, and register addressing mode. So some addressing modes we have already seen in the previous lecture. In this lecture, we will study the remaining addressing modes. Okay. So let me just quickly do the recap. What is the addressing mode? So the question that addressing mode will answer, that is, where is my operand? So basically, addressing modes, they will specify the location of the operand. So remember, addressing modes will answer this question. Addressing modes, they will answer this question, means where is my operand? So very simple. So you can easily see addressing modes, they will specify the location of the operand. And what are addressing modes? These are different ways to specify the location of the operand. Okay, so you can see addressing modes, these are different ways by which we can specify the location of the operand. The location of the operand is specified in the instruction. Okay, so very simple. Addressing modes are the different ways. There are many different ways. More than 10 ways are there. So I can say more than 10 addressing modes are there. Now I can say addressing modes are the ways by which location of operand is specified in the instruction. Okay. Now we have already seen some addressing modes. For example, we have seen immediate addressing mode, implied addressing mode. One more thing, what is effective address of operand? Effective address of operand means that is the actual address of the operand. That is the final, I can say that is the final, or I can say that is the actual address of the operand. Means if you go to the effective address, then you will find the operand. Okay, the effective address, if you go to effective address, then you will find the operand. So remember, effective address, that is the final or actual address of the operand. So remember, if you go to the effective address, then you will find the operand. The operand you will find. Okay. So let's move on. We have seen immediate addressing mode. The name itself is telling you that where is the operand? Tell me. This immediate addressing mode, what this means, let me know. Where is the operand? The name itself is telling you the operand is immediately in the instruction. Okay. You can see immediate addressing mode means your operand is in the instruction. So if you see the instruction, in the instruction, you will find your operand. So remember, operand value is present in the instruction. Very simple point. So, and what is the application of immediate addressing mode? You can use it to define constants or initialize the variables. Yes or no? So you can use it to define constants or initialize the variables. For example, I can say like load register R1 with value 15, with value 15. Okay. So remember, this indicates immediate addressing mode, right? Yes or no? This indicates immediate addressing modes, immediate addressing mode in assembly language. In assembly language. So in the assembly language, remember, this has represents the immediate addressing mode. So what this will mean, this will mean that this 15 is your operand. This will mean this 15 is the operand. Okay, so remember, your operand is in the instruction itself. Your operand value that is present in the instruction. You can see this is your instruction, this is the instruction. In this instruction, the operand value is present. So we are loading the register R1 with the value 15. Okay, with the value 15. So very simple. This is your instruction. In the instruction, you can see the operand value is present. So the operand value that is present in the instruction. And what is the application of this immediate addressing mode? The application is we can define constants, right? Yes or no? We can define constants, or we can initialize the set of variables, or we can initialize the variables. Okay, if you want to initialize some variable, that also you can do. So very simple. Now let's move on. The next addressing mode we have seen, that is implied addressing mode. You can call it implicit addressing mode. You can call it stack addressing mode. These are different names for the same addressing mode. Now, what is implied addressing mode? In this addressing mode, the opcode will tell you where is the operand. The opcode will tell you, remember, the opcode itself will tell you where is the operand. Okay, very simple point. So the opcode will tell you where is the operand. For example, if you take the example of stack-based CPU, tell me. Now, you can see instruction set architecture. So if you have this CPU, then in this CPU, you have this instruction. Now, tell me what are the operands. See, operation is addition, but you need two values to do the addition, right? Okay, if you want to do addition, you need two values. What are those two values? What are those two operands? What is the location of operands? So tell me, what is the location of operands? What is the location of operands? So that will be stack. Yes or no? That will be stack. That you already know. So remember, opcode itself is telling you the location of operand. Opcode will tell you the location of operand. This is called implied addressing mode, or I can say implicit or stack addressing mode. Okay, so very simple. For example, if you have accumulator based CPU, if you have accumulator CPU, accumulator based CPU, in this CPU, if you write this instruction add and some value X, then what will happen here? Or maybe if I write, for example, add hashtag 15. Okay, if I write this instruction, if I write, then now what will happen here? Here you can notice one operand is immediate. Can I say one operand is immediate? One operand is immediate. And what is the second operand? To do addition, you need two values. To do addition, you need two operands. What is the second operand? Where is the second operand? So the first operand will be in the accumulator, right? Actually, what the meaning of this instruction that is? The meaning of this instruction that is in the accumulator, you put accumulator plus the value 15. Okay. Now here you can notice the first operand that is accumulator. The first operand is using what? Is using which addressing mode? The first operand uses which addressing mode? Uses implied addressing mode. Okay, implied addressing mode, because this accumulator is your first operand. This is your first operand. Okay, and what is the second operand? This 15 is the second operand. So I can say the second operand uses immediate addressing mode, right? Here in this instruction, look at this instruction. In this instruction, you can notice the first operand is accumulator, the second operand is this value 15. So the second operand is using immediate addressing mode, and the first operand is using implied addressing mode. Okay, so very simple point. Another example you can say, consider this code like clear carry, CLC. Okay, clear carry. Let me tell you what is the meaning of this. The meaning of this is clear carry. Okay, CLC, clear carry. Now you tell me, what is the operand here? What is the operand here? Here again you can notice the operand is carry flag. Yes or no? Here you can notice the operand is the carry flag. Correct? The carry flag is the operand, right? Yes or no? And what is the meaning of this? What is the meaning of this? The meaning of this that in the carry flag you put 0. Okay, you put 0 in the carry flag. So remember, the operand is carry flag. That is implied or not? That is implied. Yes or no? So this is called implied addressing mode. Okay, so you can see for this instruction, clear carry, for this instruction, the operand is clear flag, carry flag. Yes or no? For this instruction, clear carry, this is the instruction. For this instruction, the operand is carry flag. So that this carry flag is basically implied. Yes or no? So I can say this instruction uses implied addressing mode. So I can say this instruction uses implied addressing mode. Or I can say implicit addressing mode. Okay, implied addressing mode. Now let's move on. The next addressing mode is direct addressing mode or absolute addressing mode. So here what will happen? You can see the instruction will have memory address, and if you go to the memory address, you will find the operand. So in this direct addressing mode, what happens? In this addressing mode, what happens? Where is your operand? Just tell me that. Where is your operand? Let me know. So operand is in the main memory. Remember, your operand is here. Okay, your operand is here. And this is a memory address. And this is a memory address. This is memory address. This memory address you will put in the instruction. This memory address you are going to put in the instruction. So in the instruction, this is your instruction. In the instruction, you will put this memory address. So very simple point. Direct addressing mode means in the instruction, we have memory address. If you go to this memory address, you will find the operand. If you go to this memory address, if you go to this memory address, you will find your operand. Okay, so very simple. For this direct addressing mode, how many memory accesses are required? One memory access required, yes or no? For this, we need one memory access. Okay, so very simple point. Now, let's move on. So you can see this is direct addressing mode, or I can say absolute addressing mode, you can call it. Both are fine, both are same. So the address field contains, the address field contains the memory address of the operand. The operand is in the main memory. The address of this operand, the address of this location, you will put in the instruction. So this is called direct addressing mode. You will need one memory reference. Okay, no special calculation is required. Basically, just go to this location and take the operand. So you don't need to do any special calculation, right? The next addressing mode, that is register addressing mode. The name itself is telling you the operand is in the register, right? Yes or no? So the operand will be in the register, and this register name, or I can say the register address, you will put in the instruction. So remember, the operand will be in the register. This operand is in the register, and this register name you will put. This register name you will put in the instruction. So the name itself is telling you register addressing mode means the location of operand, that is register. Your operand is in the register. So you can see your operand that is in the register, and this register name or the register address you will put in the instruction. Okay, so in the instruction you have a register name, or I can say register address. And if you go to this register address, if you go to this register name, if you go there, then you will find your operand. Okay, very simple. Now remember one thing. For example, if operand is in the register R5, if let's assume your operand is here, let's assume your operand is in the register R5, then remember one thing. In the instruction, either you can put the R5, okay, either in the instruction they will give you like this R5, is this clear? Or they will give you the address of this register, or they will give you the address of this register. For example, let's assume you have 32 registers, R0, R1, R2, R3, R4, R5, and so on, R31. Now you tell me, what will be the address? What will be the address of registers? Let me know. So the register address, what that will be? That will be like this. You need 5 bits, yes or no? There are 32 registers. You have 32 registers. So the register address will need 5 bits. The register address that is going to need 5 bits, right? Yes or no? Okay, so like this. So very simple. So remember, you can put here 00101. So this is the point. I hope you understood. Okay, so anyway, the point is very simple. In the register addressing mode, you can also call it register direct. Means you will get your operand in the register. So you can see in this register addressing mode, the operand is in the register, and the name or the address of this register we will put in the instruction. So in the instruction, you have the name of the register or the address of the register. And if you go to this register, you will get your operand. So there is no memory access, right? Yes or no? There is no memory access. I can say there is no memory access required. Right? You don't need any memory access. Simple. Now let's move on. The next addressing mode, that is indirect addressing mode. In this indirect addressing mode, what happens? In this indirect addressing mode, it happens that in your instruction, what you will do, you will put the memory address. Okay, remember, I am talking about indirect addressing mode. Indirect addressing mode. You can also call it memory indirect. You can also call it memory indirect. Okay. By default, indirect means memory indirect. You can also call it memory deferred. Some people, some authors, they call it memory deferred addressing mode. Okay, means they use this word for indirect. Okay, these two words, they are same. Is this clear? For indirect, they use this word deferred. Both are same. Remember. So remember, in this addressing mode, what we do, in this indirect addressing mode, what we do, your instruction has the memory address. Okay, your instruction has the memory address. Let's call it M1. Okay, so you can see this is a memory address. If you go to this memory address, If you go to this memory address, this is your main memory. If you go to this memory address, you will not find the operand. You will find another memory address. If you go to that memory address, finally you will get your operand. Finally, you will get your operand. Okay, so remember very simple point that in the instruction we will put memory address. If you go to that memory address, you will get another memory address. If you go to that, then you will find your operand. Okay, so this is the idea. So this is your indirect addressing mode. Have you seen this type of structure, this type of concept? Have you seen in the C language, in the high level language? Yes, there is pointer. So you can see this indirect addressing mode you can use to implement pointers. Okay, so you can use this indirect addressing mode, you can use this to implement pointers. Okay, so very simple point. So this is the idea. Now let's move on. And let me tell you one more thing. What is the symbol for this? What is the symbolic? What is the symbol? Or I can say notation. What is the notation for this indirect addressing mode? For this indirect addressing mode in assembly language, what are the symbol? What are the notation? The notation is either you can write like this @memory address, or you can write like this memory address in the bracket. Okay, so like this. Remember, this is the notation. This is the notation for indirect addressing mode in the assembly language. You can write @m, or you can put it in the parenthesis. In the parenthesis you can put. So very simple. Now let's move on. So for example, you can see here in this, you can see this basically represents indirect addressing mode, right? Yes or no? This basically indicates indirect addressing mode. Indirect addressing mode. Now you can easily see what this means. This means that if you go to this A is memory location. This A is memory location, or I can say this A is memory address. If you go to this memory location, you will get another memory address. If you go to that memory address, finally you will get your operand. Okay, so this is your indirect addressing mode. Let's move on. So we have seen all the addressing modes. So I can say 5 addressing modes that we have seen. I've done the revision of all of them. Now let's solve this question. Okay, so far we have seen 5 addressing modes. Now let's do the practice of all these 5 addressing modes. So you can see this is a standard university question I have taken. From a standard university, I have taken this question. Let's solve it. Given the memory values are already given to you. Given the memory values and one address machine with an accumulator, there is accumulator, and these memory values are given. What actually this means? Word 20 contains 40. What this means? Please tell me what this means. It means in the memory, remember, this address contains the value 40. Okay, yes or no? Similarly, this address contains the value 50. This address contains the value 60. Okay, so similarly, this address 50 contains the value 70. So this is the point. So these are the addresses, remember, because read the question. This is saying given the memory values are given to you. Okay, given the memory values, you can see. So actually this word 20 contains 40. This actually simply means that your memory address 20 contains 40. Okay, contains 40. You can understand this from this question, because the question is already saying that consider the memory values. So you can see here you have 40, here you have 50, here you have 60, here you have 70. Okay, now the question is saying that what values do the following instructions load in the accumulator? Okay, these instructions, what they will load in the accumulator. Accumulator is implied, right? Yes or no? In all these instructions, accumulator is implied. Okay, accumulator is implied in all these instructions. Accumulator is implied. So you can see the question is, we are loading the values in the accumulator. The question is asking what values the following instructions will load in the accumulator. Tell me what will be the answer for this question. Let me know in the accumulator what value this will put. Just tell me the final answer, because this is immediate addressing mode. Immediate addressing mode means this itself is the operand. This itself is the operand. Okay, this itself is the operand. So in the accumulator, what you will put? In the accumulator, you will put 20. Okay, in the accumulator, you will put 20 because remember, immediate addressing mode means the instruction has operand. The instruction itself has operand. So this 20 itself is the operand. So in the accumulator, you will put 20. Is this clear? Let me know. What about option B? Please tell me. What is the answer for option B? What will be the answer for this B? For this B, load direct 20. Direct 20. This is direct addressing mode. So this 20 is memory address. Yes or no? This is the memory address. Also, this is the effective address because this is the direct addressing mode. So this is the effective address or not? Please tell me. This is the direct addressing mode. In the direct addressing mode, this is the effective address, right? If you go to this address, you will find the operand. Okay, this is the address of operand. This is the address of operand. If you go to this address, you will find the operand. So you can see, if you go to this memory address, you will find your operand, which is 40. So this 40 is your operand in the direct addressing mode. Okay, we are solving this question. So for this question, the answer will be 40. In the accumulator, you will put 40. Okay, this will be the answer for this question. Tell me the answer for the next one. Load indirect. Indirect means, remember, this is a not effective address. This is memory address. This is memory address where you will find effective address. Yes or no? If you go to this memory address, you will find, okay, here you will find in the, okay, so if you go to this memory address, you will find effective address, right? Yes or no? In here, you find effective address. You find effective address. So very simple. So remember, this is indirect addressing mode means if you go to this 20, you will find effective address. Okay, you will find effective address means this 40 is the effective address. Is this clear? Okay, if you go to 20, you will find effective address. Means this 40 is the effective address. Now, if you go to 40, you will find the operand. Now, if you go to 40, you will find your operand. So the operand is 60. So in this question, the accumulator will contain the value 60. Is this understood? Please tell me all these questions. Very simple questions. Okay, so now tell me, what is the answer for the next one? Load immediate 30. You are using immediate addressing mode. So this 30 itself is an operand. Okay, this itself is an operand. Means this 30 itself is the operand, remember. This 30 itself is the operand. In the accumulator, you will put 30. This is immediate addressing mode. So the instruction will have operand. So this 30 is itself is the operand. Okay, what about the next one? What about the next one? Tell me. The next, load direct. Direct means this is memory address and this is a effective address, right? You know this is memory address. Also, this is a effective address. This itself is the effective address means in the main memory, if you go to this address, you will find your operand. Okay, if you go to this address, this itself is the operand. So remember, in the accumulator, you will put the value 50 for this question. Okay, what about the last one? What about the last one? Indirect addressing mode. So this is memory address. This is memory address. If you go to this address, you will find the effective address. If you go to this address, you will find effective address. So what you have here, that is 50. This 50 is the effective address. If you go to this 50, then finally you will get your operand. This is your operand. This is the operand. So for this question, I can say the accumulator will have 70. The accumulator will have 70. Is this clear? So all these questions, are they clear? Please tell me. Let me know. So did you understand addressing mode so far? So far, every addressing mode that we have seen, did you understand? Please tell me. So you can see these are the answers we have already seen for this question. These are the answers. Okay, let's move on. Now let's see the next addressing mode, that is register indirect addressing mode. The name itself is telling you register indirect addressing mode means you will put the register in the instruction, but remember this is register indirect. Okay, this is a register indirect. See, the name itself is telling you this register indirect. What it means? It means that in the instruction you will put register. In instruction you will put the register name. Okay, like for example R1, this register name you will put. But remember, if you go to R1, will you get operand? If you go to R1, will you get operand? If you go to R1, if you go to this register R1, will you get operand? If you get operand, that will be register addressing mode. See, yes or no? If this happens, then that is simple register addressing mode. If this happens, that is simple register addressing mode, right? Agree with me? Please tell me. Means in the instruction you have register. If you go to the register, you will find the operand. If this happens, then this is register addressing mode, or you can say this is register direct addressing mode. This is register direct. Okay, this is not indirect. So what will happen in the indirect? In the indirect, what will happen? In the indirect, what will happen? Very simple. If you go to this register, you will find effective address of, and this will be a memory address. Okay, remember, you will find effective address, but that will be a memory address. So you can see this is effective address. This is memory address and effective address. This is effective address and this is memory address. So you can see now if you go to the main memory, then you will find your operand. Is this clear? If you go to the main memory, now you will find your operand. Is this clear? Please tell me. So this is your register indirect. So in the register indirect, what we do? Very simple. The instruction will contain register. This register will contain the memory address, or I can say effective address. And if you go, then you will find your operand. So how many memory access are required in the register indirect? One memory access required. Yes or no? One memory access needed. Okay. So very simple. One memory access is needed. So this is the idea. I hope you understood this. Please tell me, did you understand? So this is register indirect. The name itself is telling you. So the register you will put in the instruction. If you go to this register, you will not find the operand. You will find another memory address. Basically, you will find the effective address. If you go to this memory address, finally you will find the operand. Okay, so this is your register indirect addressing mode. You can easily see this is very similar to memory indirect, but here you can see only one memory access you need. So this instruction will contain the register. If you go to this register location, if you go to this register, you will find the memory address. And if you go to this memory address, you will find your operand. Okay, so this is the point. This is the simple point. So very easily you can see. Okay, so you can see address field will refer to a register. You can see in the instruction, this is your instruction. This is the address field. This address field will contain the register. And remember, the value stored in this register, that is the effective address. The value stored in this register, that is the effective address. If you go to that address, you will get your operand you will get. Okay, so you can see one memory reference you need. Also, because you are putting register in the instruction, can I say smaller address field? Can I say smaller address fields? This is address field. This is called address field. This is called address field of instruction. You know, this is opcode field of, this is opcode field, and this is address field. So can you notice, because in the instruction you are putting register name, so you tell me for registers, do you need more number of bits, or for memory address you need more number of bits? For example, in your computer you have 4 GB memory. Okay, then tell me how many bits for memory address? Tell me, in your computer, let's assume you have 4 GB memory. In your computer you have that, yes or no? The main memory, the RAM, I'm talking about the RAM. So in your computer, if you have 4 GB RAM, then tell me, very simple question. If you have 4 GB RAM in your computer, which is a normal thing, yes or no? Nowadays, we have 4 GB, 8 GB, 16 GB. So this is a normal thing, right? So you tell me, for address, how many bits? Memory address. Memory address. For memory address, you need 32 bits. You need 32 bits because what is 4 GB? 4 GB. That simply means 2 power 2 multiplied by 2 power 30. Okay, bytes. So very simple. This is the idea. Now you tell me, in the same computer, in your same laptop, if you have 64 registers, in your laptop you have 64 registers. Now tell me, for register address, how many bits you need? For register address, how many bits you need? Just 6 bits. Yes or no? Just 6 bits. So you can notice who will give you less size addressing field if you use this in the instruction or if you use this in the instruction. Tell me. So that is this one, yes or no? So if we use register address in the instruction, then you will have address field will be smaller. Agree with me? Okay, you will have more space for the opcode. Okay, very simple. So this is the idea. The same thing is here. The smaller address field because you are putting register address in the instruction. In the instruction, you are not putting the memory address because memory address will take 32 bits, but register address will take 6 bits. So the size of address field that will be smaller in case of register indirect. Okay, and you can see one memory reference you will need if you compare to the memory indirect. If you compare to the indirect addressing mode, you will need one less memory reference. Okay, let's move on. So you can see this is how you can represent, yes or no? This is how we will represent register indirect or register deferred. So this is how we represent. So this indicates register indirect. Is this clear? Register indirect. So this is the notation. Remember, this is the notation for register indirect. What is that? What is the notation for register indirect? That is either @r or you put like this. Is this clear? Please tell me. Okay, so this is the notation for register indirect. Clear? Okay, let's move on. Let's solve this question. This type of similar question we have done in the last class for memory indirect. Yes or no? Let me tell you, this question is taken from IIT slides. So this similar question we have done in the last class for memory indirect addressing mode. Yes or no? For indirect addressing mode. Now what we need to do, the same question you solve for register indirect addressing mode. Okay. For register indirect addressing mode, you solve the same question because remember, indirect addressing mode, they can implement pointer that you already know. In the previous lecture, I have told you. Okay, we have already seen in the last lecture that indirect addressing mode you can use to implement pointers. Okay, so let's solve this question. Let me tell you the source of this question, that is IIT slides. Okay, now let me know. So remember, you have to use, please understand, you have to use which addressing mode? Which addressing mode? Register indirect addressing mode. Register indirect addressing mode. You have to use register indirect addressing mode. Okay, so now let's see. This is what we have to do. Register indirect addressing mode we have to use. Read the question. The question is saying an integer, let me call it A. Okay, an integer, let me call it A. So this integer A is stored. I am calling it A. This is stored somewhere in the main memory. Somewhere in the main memory. We don't know. Yes or no? Do we know where this A is stored? Tell me. Do we know where this A is stored? No. You can see somewhere in the main memory. Somewhere in the main memory. Okay, let me assume that location is Y. Let me assume that location is Y. A pointer to this integer is at address 200. Okay, so at this 200, basically, you are storing this value Y. This value Y you are putting here. Okay, now the question is saying using which addressing mode? Using register indirect addressing mode. Okay, using register indirect addressing mode, increment the number. You have to increment this. Okay, did you understand the question? What is the question? The question is, here we have to put a plus 1. Okay, here we have to put a plus 1. Is this clear? We have to increment this. That is the task. The task is we have to increment this. Okay, but remember, this is we don't know. This is unknown. This is only known data. This is only known. Okay. So this diagram, this diagram is all we know. Now you tell me what you will do. Using register indirect, first what you will do? First what you will do? First you have to load this y in some register. Yes or no? Remember, if you are using register indirect addressing mode, then you can notice basically you are incrementing what we are doing. You are incrementing the register R, some register R1. So first, what we have to do, and let's assume here you are using the register indirect addressing mode. See, just look at this line. Okay, just look at this line. You just tell me one thing. Tell me one thing. If I write this line, then okay, so what I'm saying that first basically you load in this R1, first you put the address. Okay, remember, I want to use register indirect addressing mode. Please understand. I want to use register indirect addressing mode. This is register indirect addressing mode, yes or no? Yes or no? This is register indirect addressing mode. Agree with me? This is a register indirect addressing mode. Okay, I want to use this register indirect addressing mode. So in R1, what I will put? Will I put 200 or I will put Y? Tell me, this is my question. My question is, before this instruction, in R1, what I will put? In R1, what should I put? Should I put 200 or should I put Y? In R1, what should I put? Should I put 200 or should I put Y? This is my question. My question is this. My question is, before this instruction, this R1 should have, what it should have? Should have Y or should have this 200? Think about it and tell me. Let me know. So this is the question I want to ask. Very simple. The answer will be what? The answer will be that you must have Y. Okay. In the register R1, you must have Y. You must have Y. Yes or no? Because when you have Y in the register R1, when you have Y, then this register indirect, if you do this increment, okay, let's assume your register R1 has Y. Now, if you do this instruction, if you execute this instruction, which is using register indirect addressing mode, now what will happen? Now this will be your effective address. Now this will be your effective address. Yes, this is the effective address. And here you will find your operand. Okay, very simple. Very simple. So first what we will do? We will load in this R1, we will load. What we will load? What we will load? We will load this Y we want to load. But do I know the value of Y? Tell me, I want to load Y, but do I know the value of Y? I don't know. So which addressing mode I will use here? If I write like this, then what is this addressing mode? Here I am using which addressing mode? Here I am using which addressing mode? Very simple, very good, direct. Here we are using direct addressing mode. Yes or no? Here we are using direct addressing mode. This is not the operand. Yes or no? This is not operand. This is not immediate addressing mode. This is direct addressing mode. Okay. So please understand, this is the first statement. What this will do, let me know. What this will do, this will put, remember this is direct addressing mode. This is direct addressing mode. So what this instruction will do, it will load the value Y in the register R1. Then you will increment. Then what you will do? Now this value, now in the R1 you have, okay, now you will increment, right? You will increment. Now this register R1 has A plus 1. Now what you will do? That A plus 1 you will put here. Okay, then you will store. Then you will store. Very simple. Okay, see, if you do this increment, this A you will increment. Okay, so store somewhere, store in some. So instead of increment, instead of doing increment, you just do some addition, like you just add some value. Okay, you just add what we are adding. We are just storing in some register R2. In some register R2 you store what you store. You just store 1 comma R1 comma 1. Okay, this is what you do. Okay, is this clear? So basically in this register R2 you are storing a plus 1. In the register R2 you are storing a plus 1, and then finally you store, and then finally this R2 value you store. This R2 value you put where? You put here, you put. Okay, so this is the answer. Okay, let me explain if you did not understand. So remember, the first step will be this. The first step, you load in this register R1. In this register R1, what you load? You load this. This is the direct addressing mode. Here we are using direct addressing mode. You load this value y. Okay, so please understand, we are loading the value y. This is what we are doing first. So after this instruction, what will happen? After this instruction, what R1 has? R1 has y. Yes or no? Direct addressing mode we are using here for this 200. So it means this y we are loading in R1. Now what we are doing? We are doing the addition because we need to increment. So what we can do? We can do the addition. The addition we are doing like this, that in R2 we are storing, what we are storing? We are adding two things. Number one, we are adding, this is immediate addressing mode. Yes or no? What is this? This is your immediate addressing mode. This is the immediate addressing mode. So what we can do? So what we can do? Very simple. You just in this R2, basically you are putting, remember, it means that in R2, you are putting 1 plus A. Okay, but how this A you will access? How this A you will access? You will access this A like this, using the indirect addressing mode. And finally, what you will do? Now your R2 has 1 plus A. Your R2 has 1 plus A. Now you will store. Now you will store. Remember what you will do? This R2 you will store again here, again here. Yes or no? Again here. So this is the final thing, and this will change to A plus 1. Anyway, did you understand? Please tell me. Let me know. Let me know. Did you understand? Is this clear? Okay, you are basically, finally you are storing this A plus 1 value. Again, what you are doing? Again, this value you are storing here. So this is what we are doing. Okay, anyway. So if you understood this question, very good. If you did not understand, you can skip this question. Okay, because in the GATE exam, options will be given. Yes or no? See, if this type of question comes in the GATE exam, that this table, this diagram they give you, and they tell you to increment the number, then options will be given. You can check out the options. Agree with me? Yes or no? This type of question can come in the GATE exam. It can come in the GATE exam, but options will be given to you. They will give you this type of code. They will give you which code is working. Is this code working? Is that code working? Okay, so some kind of code they will give you. Or what they can do? They can give you this code and they can ask you what this code is doing. Is this code incrementing the integer or not? So basically, remember, in the GATE exam, options will be given to you. This code will be given to you. You don't have to write the code. So just understand this code, what this code is doing. Just understand this code. Nothing else you have to do. Okay, nothing else you have to do. Is this clear? Please tell me. Let me know. Okay, let's move on. Let's solve this question. This question is also taken from a standard university. Let's see. Let's solve it. So you can see here, given the following memory values and register values, memory values and register values are given to you in this diagram. Look at this. Okay, you can see memory values are given, register values are given. So this is what the question is saying. given the following memory values and register values. Memory values, register values, they are given here. These are the register values, these are the memory values. Is this clear? Assume the load instruction loads the value at a specific address to the accumulator based on the addressing mode. So what this load instruction will do? It will load the value in accumulator. Very simple. So this load instruction loads the value at a specific address to the accumulator. Okay. Based on the addressing mode. What values do the following instructions load into the accumulator? So tell me the answer now. Load direct 100. What is the value you will get in the accumulator for this? In the accumulator, what you will get? If you have this instruction load direct addressing mode. So this is what? Just tell me this point. In the direct addressing mode, what is this 100? In direct addressing mode, what is this 100? You tell me. Simple question I'm asking. In the direct addressing mode, what is this 100? This 100 is the memory address. This is the effective address. Yes or no? This is effective address and this is the memory address. This is the memory address. Okay. So you go to this memory address, you will find your operand. You go to this memory address 100, you will find your operand. What is the operand? The operand is 101. Yes or no? You go to this memory address, you will find your operand. So go to this address, you will find the operand that is 101. So the accumulator value will be, for this question, the accumulator value will be 101. Understood? Tell me the next. Load indirect 100. What this will do? This is indirect. So this is memory address. This is memory address. If you go to this address, then you will get what? If you go to this address, means if you go to this memory address, what you will get? You will get effective address, right? Yes or no? You will get another address you will get. You will basically get a effective address. So in the accumulator, what you will put? In the accumulator, what you will put? Just tell me. So very simple. If you go to this 100, if you go to this 100, you will find effective address. So this is the effective address. If you go to this address, you will find the operand. The operand will be 102. The operand will be 102. Okay. So you can see effective address is 101. If you go to this 101, you will find the operand. This is the operand. What about the next one? What about the part C? Load register direct. This is register direct. Register direct is same as register. Register direct. So this is the register. Okay, this register will contain what? In the register direct. This is the register addressing mode. Register addressing mode. So this will contain the operand. Yes or no? This register will contain the operand. So this register C will contain the operand. Okay, so you can see the answer will be 110. For this question, the answer will be 110. What about this last one? Load register indirect. Register indirect. So if you go to this C, you will get what? You will not get operand. You will get effective address, which will be a memory address, right? Which will be a memory address. So very simple. If you go to this C, you will get memory address. If you go to this C, you will get memory address. If you go to this address, you will find your data. So the operand will be 103. So the operand is going to be 103. In the accumulator, you will put 103. Okay, very simple. All these questions, very simple. Let's move on. Tell me the answer for this question. Memory access. How many memory access required for the following instructions? How many memory access we need for the following instructions? If you have these instructions, how many memory access we need? Suppose every instruction is one word long, as well as every address. Every instruction is one word long. So these are the instructions I1, I2. Okay, how many memory access we need for these instructions? Every instruction is one word long. What that means? Every instruction is one word long. What that means? It means in a single page, you can get the instruction, yes or no? It means one memory access for instruction fetch. Agree with me? For instruction fetch. Yes or no? You need only one memory access for instruction fetch because every instruction is one word long. Every instruction is one word long. So you can see the CPU, the entire instruction you can fetch instruction we can fetch in one memory access. Because remember one thing, when the CPU will generate some address, then in one memory access, how much data CPU will get? Please tell me. When the CPU will generate some address in one go, okay, in one time, I can say in one memory access, how much data CPU will get? That is one word. Oh, you can see every instruction is one word. Every instruction is one word. So I can say the entire instruction you can get, the entire instruction we can get in a one memory access. So one memory access for instruction fetch. Is there any other? Is there any other? Let me know. So just you tell me about this instruction. Look at this instruction I1. For this instruction I1, you tell me, okay, one memory access for instruction fetch. One memory access for instruction fetch. Yes or no? That's it. After that, nothing. In R1, you are putting R2 plus R3, then nothing. Yes or no? That's it. Agree with me? Because after that, you are putting R2 plus R3, you are putting in R1. Okay. So you don't have to access the memory again. What about this instruction? What about this I2 instruction? In this I2 instruction, what will happen? One memory access for fetch plus. You can see one memory access here. This is the register indirect. Yes or no? Plus one memory access due to register indirect. Due to register indirect for operand fetch. Yes or no? One memory access for operand fetch. You will fetch the operand for operand fetch due to register indirect. Okay. So you can see one memory access for operand fetch due to register indirect. Due to register indirect. So finally your answer is how much? For this question, finally your answer is how much? For this entire question. Tell me the answer for this question. The answer will be 3. Yes or no? The answer is going to be 3. Is this clear? Please tell me. So this type of questions they can ask you in the GATE exam. Okay, very simple question. Let's move on. So you can see here, for this instruction, one memory access to fetch. Okay, because you will read the instruction, that means you will fetch the instruction. And for this instruction, two memory access, one to read the instruction, okay, and another to read the values, to read the operand for operand fetch. Okay. Tell me the answer for this question. So you can see an address field in an instruction contains decimal value 14. Okay. So basically the address field that contains the value, this instruction you have some instruction. In that instruction, the address field, okay, there is opcode, and there is a address field. There is address field. Now this address field contains the value 14. The decimal value 14. Okay, you can see. So the address field in an instruction contains the value 14. Where is the operand located? Where is the operand located? Tell me, where is the operand located? If you have immediate addressing mode, where is the operand located? The operand is located where? Where is the operand located? In the immediate addressing mode, what is the effective address? In the immediate addressing mode, what is the effective address? Just tell me. In the immediate addressing mode, the effective address is instruction itself. Yes or no? The effective address is instruction itself. The instruction the address field of the instruction. Can I say, sorry, the effective address. The effective address is instruction itself, right? Yes or no? Instruction itself is the effective address. Agree? The effective address is a instruction itself. Anyway, for this question, the operand itself is 14. Operand itself is 14. 14 is the operand. Agree with me? Please tell me, did you understand this? See, very simple question. In the immediate addressing mode, the instruction itself is your effective address. Means. In the instruction, you will find your operand. Okay, the instruction itself is your effective address because basically in the instruction you will find the operand. So your operand is 14. What about the second one? What about this one, direct addressing? So the effective address is 14, right? Here this effective address is 14 and your operand is where? Operand is at location at address 14. Yes or no? At memory address 14. Is this clear? Your operand, where you have operand it at the memory location 14. Very simple. What about the next one? What about the part C? Indirect addressing mode. Here what will happen? Here I can say your operand, where you will find the operand? The operand you will find at the address contained at the address contained at address 40. Contained at address 14. Yes or no? Is this clear? Agree with me? Okay, so your operand, you will find your operand at the address which is contained in the address 14. Okay, basically, you go to the here you will find the effective address, and there you will find your operand, and there you will find your operand. Okay, so there finally you will find your operand, right? Agree? Very simple. Yes or no? So basically what you do, go to the memory at this address, then again go to the memory at that address. Okay, that will be your operand. That is your operand. That is your operand. Is this clear? Your operand is go to the memory at location 14. What you get, the content you get, go again there in the memory. Okay, go again to the main memory at that location. You will find your operand. So you can see. Okay, and what is effective address here? If someone asks you what is the effective address, then that is simply just the content at memory 14. Yes or no? That will be just content at memory location 14. Okay, at memory location 14, the content at memory location 14, that is the effective address. Tell me about this. Register addressing means this is the register. Okay, in the register addressing means register number 14. Register number 14 contains your operand. Register number 14 will contain your operand. Yes or no? Because this is the register address. Okay, if you have register addressing, then this is the register address. Or I can say register number. So R14 will contain the operand. What about the next one? Register indirect. Register indirect means if you go to this R14, you will get your effective address. Okay, if you go to this effective address in the main memory, you will find your operand in the main memory. So this is the idea. Means very simple point. In the main memory, at which address you have to go? In the main memory, you have to go to the address which is contained in R14. Okay. In R14, some address is there. In R14, some address is there. Go to that location in the main memory. Go to that location in the main memory. Is this clear? So this will be your operand. So very simple. So remember, R14 contains effective address. You go to that address, you will get your operand. So these are the questions. Very simple. Let's move on. So these are the answers you can easily see. In the immediate addressing mode, 14 itself is your operand. Okay, means your operand is the address field. Can I say? Your operand is the address field. Your operand, that is the address field. In the direct addressing mode, the memory location 14, that is your effective address. I can say here you will find the operand. Okay. Next, the memory location. So basically all these questions we have already seen. You can just check it out. This answer, you can check it out. Let's move on. Now we will study few more addressing modes. And these addressing modes, they are displacement based addressing modes. Okay, now remember, we will study 3 addressing modes, which are displacement based addressing modes. What this displacement based addressing modes means, let me tell you. But before that, let me tell you that this displacement based addressing mode, there are 3 modes. Displacement based addressing modes. Okay. So there are 3 addressing modes which you can put in this category. Okay, which you can put in this category. One is relative addressing mode. One is relative addressing mode. Another is indexed addressing mode. And another is a base register addressing mode. Base register addressing mode. Okay. So these 3 addressing modes we will study, but these three addressing modes, they are put in this category, that is displacement based addressing modes. Means in these 3 addressing modes, the calculation is very similar. Okay, all of them are displacement based addressing mode. Now let me tell you what this means. So what is a displacement based addressing mode? Displacement based addressing mode. In this addressing mode, what happens? In this addressing mode, your instruction has 2 things. Your instruction will have 2 things. One is register and another is some value. Okay, another is let's call it A. Okay, so remember, this A, either it can be a constant value, or this can be memory address. Okay, so basically this A either can be memory address or A can be constant value. So don't worry, that will become more and more clear. So you can see in the displacement based addressing mode, there are 2 things. What are the 2 things? What are the 2 things? One thing is a register. This is some register. This is a specific register. This is a specific special purpose register. Special purpose register. Is this clear? This is a specific special purpose register. So very simple. Remember this R. This R is a specific special purpose register. Normally this is special purpose, but this can be general purpose also. Okay. Normally this is special purpose. Okay. Most of the time this will be special purpose, but it can be general purpose also. Okay. So now you can see in this instruction, you have 2 things. One is your register. There is register. So you can see you have a register, and another is a value A. Okay. Don't worry. What is this value? You might be thinking, sir, what is this value? Is this memory address? Is this what? Okay. So don't worry about this. I'm just telling you that this A, this value, some value you have. Okay. This will become more and more clear when we study these 3. Okay. When we study these 3, then this will become more and more clear what is this A. But you can see, where is the operand? That is the question, right? In the instruction, you have 2 things. There is register, there is a value A. There is a value A. Okay. Now, where is the operand? That is the question. Means what is the effective address? So let me tell you, effective address will be R plus A. Effective address will be R plus A. Is this clear? Effective address is going to be R plus A. In the main memory, go to the main memory, go to which location? Go to the effective address. There you will find your operand. There you will find our operand. Means you add these 2, then you will get your effective address. Go to that address, you will find the operand. Is this clear? So remember, very simple point. In the displacement based addressing modes, in these addressing modes, your instruction will have 2 things. One is a register and another is some A. Okay, another is A. Now the effective address will be R plus A. So if you go to the memory, at this address, you will find the operand. Is this clear? Is this clear? Please tell me. See, this is the template. Can you notice this is the template? This is just a template. This is not an addressing mode. Is this addressing mode? Can I say this is addressing mode, displacement addressing mode? No, this is not addressing mode. This is just a template of these three addressing modes. Is this clear? These three addressing mode template is called, I can say, displacement based addressing mode. Is this clear? Let me know. Means they have the same template. These three addressing modes, they have the same template. And what the template? The template is this. Your instruction has r comma a, and the effective address will be r plus a. If you go to this address, you will find your operand. So very simple. The effective address will be r plus a. That's it. The effective address will be r plus a. Is this clear? Let me know. So you can see effective address, what that will be? Effective address will be r plus a. Okay, content of CPU register, that is your R, and A, this is your A. So remember, effective address will be R plus A. Content of this register R plus this A, address part of the instruction. Okay. Now, see this diagram. See this diagram, displacement based addressing modes. See this diagram. Your instruction has two things, R comma A. R is a register. Okay. And how to find the effective address? How to find the effective address? That will be content at R plus this value A. Content at R plus value A. So I can say effective address will be A plus content at R. Content at register R. Okay, so here I can simply say this will be content at register R. Okay, content at register R. So I can say effective address will be A plus content at R. Okay, this is going to be the effective address. Is this clear? Please tell me, did you understand this template? Just tell me. This template is clear. Is this template clear that in the displacement based addressing modes, there are three type of addressing modes here. Remember, there are three type of addressing modes. Relative addressing mode. There is another that is indexed addressing mode. There is another that is base register addressing mode. These are very extremely important. So remember, all these, they have the same template, and the template is called displacement based addressing mode. So this is just a template. This displacement, this is just a template. So in this template, what happens? You have an instruction. The instruction has a register, comma, this value A. Now, I can say your effective address will be whatever is this value A plus the content of register R. That will be your effective address. If you go to that address, you will find your operand. Okay, clear? So very simple. Okay, now let's move on. Now let me tell you something interesting. That is, if you change this R, then you can get all these three. In this displacement, you can see, I told you that in the displacement, okay, in this displacement based addressing mode, what I told you that your instruction has what? Your instruction has two things. One is R, another is A. Yes or no? Let's call it address field. That's it. This is just the address field of the instruction. This is the address field of the instruction. Remember? That's it. Okay. So this is A, and this is a register. You know, this is a register. Now, depending on what is this register, three categories are there. Three addressing modes you can get. Okay. Three addressing modes depending on what is this register. So remember, depending on this register, you have three addressing modes are there. Three addressing modes are there. So basically, in all these three addressing modes, what is the difference? There are three addressing modes. I told you relative addressing mode. I told you indexed addressing mode. And I told you base register addressing mode. What are the difference in all of them? What is this register? Yes or no? Depending on this register, what is this register? Which register is this? Depending on this register, which register is this? You can have three addressing modes. Now, let me tell you. If this register is program counter, then let me tell you. First, let's see if this R is program counter. If R is program counter, then which addressing mode you will get? If this R is program counter, if this register R, this is a program counter. Okay. Then this addressing mode will be called, then it is called relative addressing mode. Then it is called, then it will be called relative addressing mode. Relative, or you can say PC relative. By default, relative means PC relative. Okay, relative means PC relative. So remember, if this register R is program counter, then it is called relative addressing mode. That's it. If this R, if this R is a, if this R is index register, there is a index register in your CPU. There is a index register in the CPU. Okay. So if this register R, this is index register, then what we call it? Then what we call it? Then it is called indexed register, indexed addressing mode. Then it will be called indexed addressing mode. Okay, is this clear? And if this R is base register, there is a base register. There is a base register in your CPU. In your computer, there is a base register. If this R is base register, then it is called what? Then it is called base register addressing mode. Base register addressing mode. Is this clear? Okay, overall, did you understand? One by one, we will study, don't worry. We will study indexed addressing mode, PC relative addressing mode, and base register addressing mode. But overall, did you understand what is happening here? All of them have the same template. Yes or no? Did you understand that? All of them have the same template. All of them, they have the same template. R, A. What you have to do? You have to add the content of R plus the plus A. Okay, so that will be your effective address. So remember, all of them, they have the same template. Depending on what is this R, what is this register R, depending on that, you can create 3 addressing modes. If this R is program counter, then it will be called relative addressing mode, or you can call it PC relative addressing mode. If this R is index register, then it will be called indexed addressing mode. If this R is base register, it will be called base register addressing mode. Okay. Now let's see one by one. All of them we will study one by one. I know you did not understand. Yes or no? You did not understand this. Okay, but I have just told you the template. Okay, now we will study all of them one by one. Now let's start with the first one, that is indexed addressing mode. Okay, this indexed addressing mode. Let me tell you, this addressing mode is used for array creation, for array implementation. Now you will tell me everything. Okay, this is your responsibility to tell me everything about this addressing mode. I promise you one thing. If you did not study this addressing mode in your life, then also you can tell me the behavior, the syntax, the semantics of this addressing mode. Basically, you can tell me all about this addressing mode. Just answer my questions. Okay, I'm asking some questions. You just keep answering those questions back to back. Do you know what is an array in your C language? Do you know what is an array in C language? In your high level language, do you know what is an array? Yes, you already know the array. Okay, the array is something like this. Let's assume you have some integer array. Let's assume you have some integer array A. Okay, let's assume you have some integer array A. Okay, so this is your integer array A. Now every element is integer. Agree? Every element is an integer. Okay, now you tell me one thing. Let's assume integer size, let's assume that is 4 bytes. Okay, every integer is taking, let's assume 4 bytes. You tell me one more thing. In your C language, can you change the array, this base address? This array name represents base address, right? This array name represents the base address of the array in the C language. Yes or no? In C language, array name represents base address of the array. Agree? Yes or no? Please tell me. You have already studied C language. Let me know. Yes or no? So you can easily see that in the C language, the array name will represent the base address of the array. Let's assume the base address of the array I'm giving you, let's assume that is 100. That is the base address. Tell me, this element, you call it A0, right? This element, you call it A0. This element, you call it A1. This element, you call it A2, right? Agree or not? In the C language, I am talking about the C language. I am talking about the C language. So this is your A0, this is your A1, this is your A2, this is your A3. Tell me what is the location, what is the address of this? What is the address of this? I can say this element. Tell me this A1, this element, what is the address? That is 104, because integer size is 4 bytes. Every integer is taking 4 bytes. So this will be 108, this will be 112. Okay. Can you change the array base address? The array base address, can you change? The array base address, can you change? No, we cannot change the array base address. Okay, this array base address we cannot change. This is fixed, right? Yes or no? If you remember. Okay, so remember, this cannot be changed. This cannot be changed. Yes or no? Very simple. Is this clear? So very simple that this base address you cannot change. Okay. Now you remember this index addressing mode. Let me tell you, this indexed addressing mode, this is actually used for array implementation. This is actually used for array implementation, in assembly language. Okay. In the assembly language. Now what that means? So remember, very simple point. This indexed addressing mode, remember just this line, that indexed addressing mode, this is used for array implementation. We use this for array implementation. So array implementation we can do using indexed addressing mode. Okay. Now. So if you want to implement an array, which thing you will keep fixed? Which thing you will keep fixed, or I can say constant? Which thing you will keep fixed constant? Because for array implementation, two things you need, right? Okay, you need only two things. What are those two things? That is, one is base address. One is base address. Agree? What is the base address of array? One is base address of array. And what is the second thing? Tell me. What is the second thing? That is the index value. Agree? Yes or no? Please tell me. That is the index value. Do you agree with me? Two things you need. Yes or no? For the array implementation, this is your array. For this array implementation, this base address I need and index value. Only two things I need. Agree? Okay. So just tell me, which of them is constant? Which of them will be constant? Which of them I should keep constant? Which of them should I keep constant? I should keep which of them constant? The base address of array. Very good, very good, very good. The base address of array I should keep constant. And what should I keep changing? Means, what should I keep variable? What should I keep variable? I should keep this index value variable, so that I can access A0, A1, A2, A3, whatever I want to access. Whatever I want to access, I can access it. Okay. Is this clear? So far, is this clear? Now you tell me. I told you that indexed addressing mode. I told you indexed addressing mode has two things. Instruction will have two things. I already told you that instruction will have two things. One will be register and another will be some value. Okay. This register, this will be index register. We will call it index register. This is a index register. Okay. Now you just tell me, in this register what you will put, and in this A what you will put. Means, tell me. If I put the base address, the base address, should I put in the instruction or should I put in this register? Just tell me this point. The base address of the array, should I put in the instruction or should I put in this register? Which you can change? Which of them you can change? Tell me, which of them you can change? Means, the base address of the array, if I put here, you can change it, right? Yes or no? But so I should put it here. Agree with me? And the index value I should put it here. Is this clear? Please tell me. Is this point clear? Remember, very simple, that for array implementation, you need two things. One is base address of array, another is index value. The base address of array, you will keep it fixed, you will keep it constant. And this index value you can change, like 0, 1, 2, 3, whatever you want, you can change it. You can decrement, you can increment. This index value you can change. So tell me, this index value where you will put? in the instruction you will put, or in the register you will put this index value. This index value you will put in the register. Yes or no? Very simple. So in the index register, you will put index value. So here you will put index value. Did you understand why we are putting index value here? Please tell me, did you understand why we are putting index value in the register? And why we are putting the base address of array in instruction? The base address of array in instruction. Okay, so this A, remember, this will be the base address of array. And this R, this index register will hold the index value. This will hold index value. Okay. And the reason, did you understand? See, if you want to remember, then you can remember like this, that index register, index value. That is a trick to remember, but that is not the concept. Agree? See, this is a trick to remember, that index register will hold index value, index, 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 index. So index register will hold index value, but that is not the concept. The concept is very simple. The index value you can change, you can increment, you can decrement, all these things you can do. Okay, you can increment, you can decrement the index value. You can change it, you can keep changing it. Okay, but the base address you will keep fixed. So that is the reason. Remember, this base address we will put in the instruction. In the instruction, we will put the base address of the array. And in the index register, you will put the index value. This index register you can put here. This R is your index register. Understood? Let me know. What will be the effective address? What will be the effective address? The effective address will be this A plus the content in R. The content in index register. The content in index register. Okay. This will be the effective address of the operand. So very simple. Is this clear? Let me know. Is this clear to everyone? Please tell me. Now I want to ask something very important. This point, remember, the point that I will ask you now, based on this point, there was a question in GATE 2023 and many students made mistake. Many students, they made mistake. Can you differentiate between C syntax? Can you differentiate between C syntax versus addresses versus physical addresses? Can you differentiate physical addresses? Okay. C syntax. C is a very high level language. Can you differentiate between C syntax versus, I can say, low level? Means, can you differentiate between high level and low level? High level and low level. Let me ask you a question. You will understand what I'm asking. So let me ask you this question. See, you know that, let's assume integer size. I'm giving you the integer size. Let's assume integer size is 4 bytes. Okay. And you have this array A. You have this array A. You have in this array A, these are the 4 integers. Okay. This is an integer array A. Now, this is the base address 100. Okay. This is your A0. This is a A1. This is a A2. This is a A3. Okay. Yes or no? This address will be 104. This address will be 108. This address will be 112. Okay. Right. Now you can notice in the C language. See, in C language, remember this A represents 100. A represents 100. In the C language, if I write something like this, that if you do A1, okay, then what that means? In C language, if I ask you what is address of A1, what that will be? In C language, if I ask you what is address of A1, what that will be? A1. I am asking, in the C language, this is the index value or not? Just tell me, in the C language, this is the index value or not? The index value of this element is 4 or 1. The index value of this element is 4 or 1 in the C language. That is 1. Tell me the index value of this, is that 3 or 12? The index value of this, that is 3 or 12. That is 3 in the C language, right? Yes or no? So if I ask you ampersand address of A1, that you will say 104. But tell me, for the same thing, for this element, focus on this element, for this same element, Now you tell me about instruction, your assembly language instruction. Okay, your assembly instruction. So now you tell me, in the instruction you will put what? In the instruction you will put the base address. That is fine, there is no problem. You will put base address. So this is your A, this is your A, that is fine. Okay, you have index register. This is a index register R. This R is your index register. In the index register, what you will put for this element? Just tell me. This is my question. My question is, in the index register, okay, you will put the index value, right? It will hold the index value. It will hold index value, right? Holds index value, which you will add to 100. Remember that you will add to 100. Okay, so now you tell me, this value, this should be what? What should I put here? If I want to access this element, I should put 1 or 4. I should put 1 or 4. I should put 4, because remember, because the hardware, the processor will simply add these two. See. If you put 1, the processor will add 101. Okay, if you put 1, then the processor will add these two and will make 101. So that is the reason. The correct answer is what? The correct answer is you will put 4 here, so that these will add and they will become 104. Is this clear? Please tell me. Understood? This is what I'm telling you. That on the low level, these type of things will not work. On the low level, everything is very straightforward. Yes or no? On the low level, these type of clever things will not work. Is this clear? Please tell me. See, in the C language, this will work. In the C language, these 3 you can put that. Okay, this is the index value. Who will do this conversion for you? Like this conversion, who will do for you? The compiler will do it for you. Okay, so basically you are having the facility. Remember, you are having the facility only. The compiler is doing the conversion and all these things. Is this clear? So basically you can write this, you can write A1, but ultimately the compiler will create 4 here. Is this clear? Please tell me. The compiler will put 4 here. Is this understood? Let me know. So very simple. Is this point clear? Okay. So let me ask you one more question here in this. Just let me remove. Okay. You tell me, if I want to access, for example, this, not this, if I want to access A3, then what I will do? I want to access this element. I want to access this element. Then what my index register should have? What my index register should have? Tell me. Because my instruction will have base address, right? In the instruction, there will be base address. There will be base address. Okay. So this should have what? This should have 12. So that I can add these two, right? Because ultimately what will happen? What will be the effective address? That is A plus the content of R. The content of R. That is 112. Finally, the effective address is 112. Understood? Let me know. Okay. So this will be called index value. So remember, this will be called index value only. We will call it index value. But this is not the index value of C language. Yes or no? We will still call it index value. We will call it index value, but this is not the index value of the C language. Now forget about the C language. Is this clear? Now you are dealing with the hardware. You are dealing with the addresses. Now forget about C language. Now there is no compiler to help you. There is no compiler to do your work. Now you have to do everything. Okay, yes or no? You have to add the exact value. You have to add the correct value. So we will call it index value, but it is not your C language index value. Okay, forget about C language now. So is this clear? Please tell me. So what happens in the index addressing mode? Let me tell you the summary. In the index addressing mode, what happens? Tell me what happens. In the instruction, what you will do? In the instruction, what you will do? In the instruction, you will put 2 things. Okay, you will put 2 things. One is index register, another is A. Okay, this R will be index register. This R will be index register. And what is this A? Let me know what is this A. This is the base address of array. This is the base address of array. This index register will hold index value. It will hold index value. And your effective address will be this A plus content of R. Okay. Content of R. This will be your effective address. Is this clear? So very simple. Now let me tell you one more thing. If this index register is a special purpose register, okay, this index register, let's talk about this index register. Either this can be a special purpose register, this index register. Either it can be a special purpose register, means a very special register you can designate only for index register. Either this is a special register, okay, or this is any general purpose register. Okay, some general purpose register means you can select some general purpose register to work like a index register. Okay, so it can be some general register. Now just you tell me, in which case we don't have to specify the index register in the instruction. In the instruction, remember this index register, either it can be special register, either it can be special purpose register, or it can be some general register. Either it can be some special purpose, means there is a register which is only index register, or you can use some general purpose register to act like index register. Now you tell me, in which case you don't have to put the index register, you don't have to specify the index register in the instruction. Tell me, in which case? When it is a special purpose, yes or no? Means if in your CPU, inside your CPU, if this is a special purpose register, inside your CPU, if there is a register which will only work as index register, inside your CPU, if you have a register which will only work as index register, means this is a special purpose register, then you don't have to mention it. Okay, so remember, if index register, let's call it R, let's call it I, or index register, let me call it IR, but that is instruction register. So let me call it some, okay, just let me call it IX, something like that. Okay, let me call it IX. No problem. Let me call it IX. So remember, if this index register is a special purpose register, if it is some special purpose register, means in your computer, in your CPU, if there is a special purpose register which is index register, then your instruction, then it is implicit. Yes or no? Then your instruction will not specify this. Is this clear? Then it is implicit. Then it is implicit in index, in the instruction. In instruction using index addressing mode. Okay. And if this is some general purpose register, means some general purpose register you are using as a to store the index value, some general purpose register you are using to store the index value, you are using some general purpose register to store the index value. In this situation, what we need to do? Then it is specified, yes or no? Then it must be specified. Then it must be specified in the instruction. Okay, correct? Then it must be specified. We must specify this in the instruction. Okay, in the instruction we should specify. So remember, if you are using a general purpose register, some general purpose register you are using to hold the index value, in this situation you have to specify here, and this is your A. And remember, if it is a special purpose register, then there is no need to specify. Is this clear? Please tell me, let me know. So if this index register, if this is a special purpose register, then there is no need to specify this in the instruction. You can see there is no need to specify. Okay, you don't have to specify, but what will be the effective address? Effective address will be same, but you don't have to specify this, yes or no. Effective address will be same. Similarly here, if you are using a general purpose register to hold the index value, then you must specify that register. Okay, which general purpose register you are using to hold the index value, you must specify. Okay, effective address will be again same. Effective address will not change, that will not change. Okay, let's move on now. So we have seen this index and addressing mode. This is what we have seen. I hope you understood this. Please tell me, is this clear? Let me know. So whatever, everything we have seen. Okay, now let's move on. Let's solve this question. This is a question from a standard book. Now let's solve it quickly. Tell me the answer. Suppose we have the instruction load 1000. Given that memory and register R1 contain the value below. You have an instruction load 1000. Your instruction is load 1000. Now let's see. First we will do this first one. Okay, first let's do this first one. What is your instruction? Your instruction is load 1000. This is your instruction. This is the instruction. Okay, now you can see this memory is already given to you and register R1, that is 200. Assuming R1 is implied in the indexed addressing mode, means when you solve this question, when you solve this fourth question, then your R1 will be your, what will be R1? Tell me. What will be R1? That will be your index register. Yes or no? That will be your index register. Okay, is this clear? So very simple. So remember, this R1 is going to be your index register when you solve the fourth question in the indexed addressing mode. So you can see in the indexed addressing mode, this R1 is implied. This R1 will be your index register. Determine the actual value loaded in the accumulator. What value you will load in the accumulator? In the first question, what will be the answer? Immediate. You can see we are using immediate addressing mode. So this 1000 itself will be what? This 1000 itself will be the operand. This itself will be the operand. So the answer is going to be 1000. Okay, tell me the next one. Tell me the next one. This part B. Tell me this one. In the direct, your instruction is load 1000. So now this is a memory address. This is your effective address. This is a memory address. This is a memory address. So go to the main memory. Go to the main memory. This is the operand. So your operand is going to be 1400. Correct. What is the answer for the next one? For indirect. For indirect, this is your instruction load 1000. So this is memory address. Again, this is a memory address. Now, if you go there, you will find the effective address. This is the effective address. If you go there, then you will find the operand. Okay, so I can say your answer will be 1300. What is the answer for the last one? What is the answer for the last one? Indexed. Indexed. This is your, in the index addressing mode, this R1 is your index register. So this R1 is your index register. So this is your index value. This is the index value. Okay. If this is the index value, what the base address? This will be your A. Yes or no? This will be your A. This is the base address of array. Correct. Agree with me? So this 1000, this is your A. This is your A. I told you. This is your A. So in this situation, what will happen? What is the effective address? In this situation, the effective address will be this 1000 plus the content of R1, that is 200. That will be 1200. This is the effective address. This is the effective address. So this will be operand. So this is going to be operand. Is this clear? This will be operand. So your answer will be 1000. Please tell me, understood? Your final answer will be 1000. Let me know, because effective address will be 1200. Your effective address will be the base address of the array plus the index value. So that will be 1200. And at this location, you will find operand. So your operand will be 1000. This question is clear to everyone? Please tell me. Let me know. Let me know. Okay. So let's move on now. This example you can self read. Okay. This example you can see. In the immediate, what will happen? If you have this instruction, load hashtag 2. Here, what will happen? In the accumulator, you will put 2. You can see load 2. In the direct, what will happen? In the direct, this is the effective address. If you go there, you will find your operand. So you will load 47. In the indirect, what will happen? In the indirect, you go to 2, you will get effective address. You go there, and you will find the operand. So 38 you will load in the accumulator. In the indexed, what will happen? This is your register X, this is your index register. So you will add these two, right? Yes or no? 2 plus 4, that is 6. So go to 6, that you will load in the accumulator. Is this clear? This diagram, in this diagram, you can see these 4 addressing mode: immediate, direct, indirect, indexed. Okay, so these are given to you in this diagram. Please tell me, did you understand? Let me know. Okay, let's move on. Let's solve this question. This is GATE exam question. So this is GATE 2006 question. Let's solve it. The memory location 1000, 1001, 1020 have data values 18, 1, 16 respectively. Before the following program is executed, this program is given to you. Which of the following statement below is true after the program is executed? After the execution of the program, basically what is the content at each memory location? This is what the question is asking. Okay. So what is the initial setup? Just tell me what is the initial setup. You can see the memory location 1000. There is a memory location 1000. There is memory location 1001. And there is memory location 1020. Okay, so these are the memory locations. And they have the data 18, 1, 16. This is the initial setup. Yes or no? This is the initially. So I can say this is the initial setup I have given to you. Now, initially. So you can see. Now let's start the program execution. Tell me after this instruction what will happen. Just tell me that. Just tell me after this instruction what will happen. Let me know. Once you execute this instruction, what will happen? Let's execute this instruction. This is saying move immediate. Okay, you can see this is meaning is already given to you. Move immediate, immediate addressing mode. Move immediate. What it means? Now your register RS that has the value 1. Okay, your register RS that has value 1. Yes or no? So that is fine. What the next thing? Now your register RS that has value 1, remember? Okay, now let's do this. After this instruction, what will happen? After this instruction, load from memory. We are loading from memory. Okay, so you can see we are loading from memory means in this RD, we are putting what we are putting? Tell me what we are putting here in this RD. We are putting 1000. Basically, in the memory, you go and you check at 1000 plus 1 what you have. Okay, at 1000 plus 1 what you have. Actually, this is your representation of indexed addressing mode. See, here, this is the representation of indexed addressing mode. Let me tell you, this is indexed addressing mode representation. Indexed addressing mode notation, let me tell you. So this indexed addressing mode, what is the notation for this? Let me tell you, the notation is like this, that I told you that in the instruction, you have 2 things. One is R, another is A. Yes or no? Do you remember? Yes or no? This A will be base address of array. Base address of array. And this R will be your index register. Index register. Right? Yes or no? This R, this will be your index register. It will hold the index value. It will hold index value that you already know. So this is the indexed addressing mode. Okay. Now you can see the notation. Let me tell you, the notation is this. Okay, we notify like this, that A R. This is how we notify. Is this clear? This is how we notify. So this is the notation. Remember, this is the notation. This is the notation for indexed addressing mode. Is this clear? Indexed addressing mode. This is the notation for indexed addressing mode. So here, this A, this will be your base address of the array. This A will be the base address of the array. And this R, this is your index register, which will hold the index value. So what will be the effective address? Please tell me what will be the effective address. That will be A plus the content of R. The content of R. Yes or no? Okay, this will be the effective address. Effective address will be A plus content of R. So remember this notation, please focus on this. This is the notation for indexed addressing mode. This is the notation for indexed addressing mode. So here you can notice this instruction is given to you, load RD 1000 RS. See, this instruction is given to you, load RD 1000 RS. And you already know the RS value, that is 1. This is the RS value. So what is this? Which addressing mode is this? Please tell me. Please tell me which addressing mode is this? I told you that this is your indexed addressing mode. Indexed addressing mode. Okay, there are two things here. There is this we call A. We call it A, and this is your address. This is your register. So what will be the effective address here? What will be the effective address? That will be 1000 plus the content of RS. That will be 1. So this will be the effective address. Remember, this will be the effective address. If you go to this address in the memory, if you go to this address in the memory, there you will find the operand. There you will find the operand. Okay. This operand you have to load in R6. Is this clear? So in R6, you have to load, what you have to load? You have to load at this location the value. Okay, is this clear? Okay, so you can see at this location, at this memory address, this is your memory. At this memory address, what you have, that you have to put in this RD. This is not R6, this is RD. Okay, so this is RD. So in this RD, you put this. Is this clear? So you can see in the RD, we will put what you have at location 1001. So you can see what we will do in RD, what we will have now. After this second instruction, what RD will have? Please tell me. What RD will have? You can see at this location, look at this location. At this location, you have this value. This value you will put here. So RD has 1. Okay, very simple. So now remember, RS has 1, RD has 1. Okay, RS comma RD, they have 1. RS has 1, RD has 1. Okay, after the next instruction, what will happen? After this instruction, what will happen? This is add immediate. Add immediate. So in the RD, you will put, what you will put? In the RD, you will put RD plus immediate. Yes or no? RD plus 1000. RD plus 1000. This is what you are going to do. So in RD, you will put RD plus 1000 because this is add immediate. Okay, so this is the meaning. In RD, you will put RD plus 1000. So now your RD is what? Now your RD, that is 1001. Yes or no? Now your RD, that has become 1001. So quite simple. Okay, finally you tell me. Now remember your RD. This RD has become 1001. Okay, now after this instruction, what will happen? After this instruction, what will happen? Store immediate. This is the instruction you have. Store immediate. Store I. Here you have 0, RD, 20. Store immediate. So you can see this is the immediate value. This is the immediate value. Okay. And what is this addressing mode? What is this addressing mode? The instruction is store immediate. Store immediate. So this is the immediate value. And what is this addressing mode? This is your indexed addressing mode. This is the indexed addressing mode. So tell me, what is the effective address? What is the effective address? The effective address, that is a 0 plus content at R6 plus content at RD. Sorry, this is D. The content at RD. Why I'm writing R6 again and again? Okay, so that is content at RD. So you can see effective address, that is 0 plus content at RD. What is content at RD? Please tell me. Content at RD, that is 1001. So that will be your effective address. This is just the effective address. Okay. Now you will load this value 20. Where you will load this value 20? Store. You will store this value 20. Remember, this instruction is store instruction. You are storing the value 20. Where you will store the value 20? You are storing the immediate value. The instruction is store immediate, store immediate, store immediate, store immediate value. So this immediate value you will store at this address, at this 1001. Okay, so this is what will happen. So when you execute this instruction, this address will have value 20. This will have value 20. Okay, so this is the final setup. Now tell me, after the program has executed, this is the final answer. Tell me which option is correct. Memory location 1000 has value 20. No. Memory location 1020 has value 20. Again, no. Memory location 1021 has 20. Again, no. Memory location 1001 has value 20. Yes. So answer is going to be option D. Did you understand? Please tell me, did you understand this question? So a very simple question, yes or no? In the GATE exam, this type of simple questions they can ask you. So quite simple question. Okay, let's move on. So for this question, the answer will be option D. Okay. One more thing, you can see this is in this question, basically, what is this addressing mode? Here, what is this addressing mode? This is indexed addressing mode. Because indexed addressing mode, we represent like this. We represent like this. So the indexed addressing mode, this is how we represent. So here also you have indexed addressing mode. Okay. And you can see this is immediate. So this is immediate value. This is an immediate value. This itself is the operand. This is immediate value. Similarly, store immediate. Store immediate means, again, this is the immediate value. This 20, this is the immediate value. Okay. So everything is basically given. You can see add immediate. This 1000 is also immediate value. What is this 1000? Look at this 1000. This is also immediate value. Okay. So this is a simple question. In this question, you have immediate addressing mode, indexed addressing mode. Okay. So these two addressing modes you have in this question. Also, you have register addressing mode. So basically 3 addressing mode have been used in this question. Okay. And for this question, the answer will be option D. Let's move on now. Now the next addressing mode that we will study, that is relative or PC relative addressing mode. Let's study this also. What is relative or PC relative? I told you one thing, that this is displacement based addressing mode. Okay. So in this mode, what will happen? What will be your register? What will be your register? Your register will be program counter. Yes or no? Your register will be program counter. If you remember, I told you, when I told you displacement based addressing mode, what is the template? Addressing mode template. You just tell me the template. Let me know the template. Displacement based addressing mode template, that is like this. That in the instruction you have, this is your instruction. In the instruction you have a register and a value A. Okay. Now if this register is program counter, then this addressing mode will be called what? Then this addressing mode is called relative addressing mode. Then this is called relative addressing mode. Okay, we call it relative addressing mode, or you can call it PC relative addressing mode. Both are same. You can call it PC relative addressing mode. So both are same. Okay. What will be the effective address here? The effective address, that will be the content of PC. Yes or no? Plus A. A plus content of PC. A plus content of R, where R is already PC. R is program counter. So effective address will be A plus content of program counter. Is this clear? So remember, very simple. This is your relative addressing mode. Relative addressing mode. In the relative addressing mode, what we do? Tell me one thing, program counter is a special register or not in your CPU? Every CPU has program counter. Yes, every CPU has program counter. Program counter is a special purpose register or general purpose register? Program counter is a special purpose register. Yes or no? Very special register. So do you need to mention it in the instruction? Do you need to mention it in the instruction? Program counter is a special purpose register. So will you mention it in the instruction? No, there is no need to mention. Don't mention it. So very simple. Remember, in this addressing mode, we don't mention program counter because program counter is a special purpose register that you already know. This is a special purpose register. Actually, this is the most special register in your CPU. In your CPU, if someone asks you what are the most important register, what are the most important register? This is very important, a special purpose register. Okay. So you can easily see that this program counter we will not put in the instruction, right? Yes or no? In the instruction, we will not put it in the, so remember, this is implied. This is implied in relative addressing mode. Is this clear? Please tell me. This will be implied in relative addressing mode. So when you use relative addressing mode, then this program counter is implied. This program counter you don't have to mention. So what you will mention then? Then what you will mention? Some value A you will mention. Okay, some value A you will mention. Some value A. This some value A you will mention. We will call it offset. We will call it offset. This will become more and more clear why we call it offset. Don't worry. But this A, this some value A you will store in the instruction. So in the instruction, you will not store the program counter because program counter is a special purpose register. So this is implied in the relative addressing mode. Means if your instruction is using implied, if your instruction is using relative addressing mode, your instruction, if it is using relative addressing mode, then program counter is implied. Okay. So remember, very simple. This program counter we will not put in the instruction. Is this clear? We will only put this A. This A we will put. And this A will be, we will call it offset. This A is some value. A is some value. We will call it offset. What will be the effective address? Just tell me what will be the effective address. That will be this value plus the content of PC. Plus the content of PC. Is this clear? This value A plus content of PC. This will be the effective address. Okay, understood? Please tell me. Did you understand this relative addressing mode? Yes or no? Now you might be thinking, what is the need of this relative addressing mode? See, why so many addressing modes? So far, you know the application of every addressing mode. Agree with me? If I ask you, why index addressing mode is used? Please tell me. Why we study indexed addressing mode? For array implementation. Array is very important, right? In your C language, in the high level language, array is very important. So the indexed addressing mode we study, so that because that can do the array implementation. Okay, that will help you in the array implementation. Similarly, why we study indirect addressing mode? Indirect addressing mode, why we study? Because that is helpful in the pointers implementation. You can implement pointers using it. Okay, yes or no? So you can see so far every addressing mode that we have seen, you know what the purpose. Yes or no? What the importance, what the application, you know everything. But now you might be thinking that why this relative addressing mode we study? What is the reason to study this relative addressing mode? Okay, so let me tell you. Using this relative addressing mode, you can create relocatable program. Okay, that I will explain, don't worry. But see, this relative addressing mode is very important, remember. This is very, very, very important. First, let's again, just let me explain what is relative addressing mode. Just one time, let me explain. Okay. Let me explain this one time. So let's assume that this is your memory, and in this memory, at this address 100, let's assume you have a jump instruction. Okay, you have a jump instruction, and some value I'm putting here. Okay, some value I'm putting here, that is, let's assume 20. This value I'm putting here. Okay. Now let's assume every instruction is 2 bytes. Okay, just assume that every instruction, let's assume instruction size is 2 bytes. What are the instruction size? Let's assume that is 2 bytes. Okay, I'm telling you the instruction size is 2 bytes. Then tell me, if instruction size is 2 bytes, then the program counter, when you fetch this instruction, then the program counter will have which value? When you fetch this instruction, then the program counter will have value 102. Yes or no? Okay. So let me tell you, here you have this 120, and here you have this 122. Okay. So you have this 120, then there is 122. This is 122. Okay. This is 121, 101 here. This instruction will continue, right? Okay. This same instruction will continue because this instruction will basically take 2 bytes. Okay. Correct. This instruction will basically take 2 bytes. Yes or no? Is this clear so far? So this is the memory picture. Instruction size I have already given to you. Assume jump instruction uses relative addressing mode. Jump instruction uses relative addressing mode. Assume that jump instruction, this is given to you, that jump instruction is using relative addressing mode. Okay. Now you tell me, when you fetch this jump instruction, what will be now my question? See, my question is, what is the target address? What is the branch target address? Jump target address. Where you will jump? Please tell me. What is the branch target address? Branch target address. Did you understand the question? See, the question is very simple. Instruction size is 2 bytes. Every instruction is taking 2 bytes. So this jump instruction is also taking 2 bytes. You can see 100 and 101, 2 bytes it is taking. Okay. Now, jump instruction is using relative addressing mode. That is your PC relative addressing mode. My question is, what the branch target address? What the branch target address? What the branch target address? One more question I want to ask before I answer this. If jump instruction is using direct addressing mode, then tell me the answer. If jump instruction is using direct addressing mode, your jump instruction is using direct addressing mode. This instruction is using direct addressing mode. Then what will be the branch target? Then what will be the branch target? If your jump instruction, it is using the direct addressing mode, then your branch target will be 20 itself. Yes or no? Is this clear? Because this itself will be the branch target, means basically you will jump to 20. You will jump to this address 20. Agree? Please tell me. Basically, you will jump to this address 20. Agree or not? If jump instruction is using direct addressing mode, then this is the direct address. This is the direct address. So the branch target address will be 20. This you understood, right? Okay. So very simple. This you understood. Okay. Now let's come to this question. Now remember, your jump instruction is using relative addressing mode. Your jump instruction that is using relative addressing mode, not the direct addressing mode. This is using relative addressing mode. Now what will be the branch target? Branch target address. Now see what will happen. Remember, you are using relative addressing mode. When you fetch this jump instruction, then what will be the program counter value? Instruction register. When you fetch this here, then what will be the program counter value? Just tell me the program counter value. That will be 102. Program counter value will be 102. Agree or not? Yes or no? When you fetch it, when I fetch this, after fetching it, the program counter will have 102. Now, when you decode this, after decoding, what you will do? When you decode this, after decoding, what you will do? What will be the branch target address? Branch target address. Once you decode this, you will find out that this is a branch instruction. Yes or no? Once you decode this instruction, you will find out this is a branch instruction. And this is using the relative addressing mode. Control unit knows. Control unit knows. Okay, so the control unit will find out this is a jump instruction and this is using the relative addressing mode. So the branch target address will be the PC value plus this value, this is your value A, plus this value A, this is your 20, this offset, right? What we call it? We call it offset. So finally, that will be 122. So remember, your instruction will point to 122, not 120. Is this clear? So your answer will be 122. Please tell me, did you understand? Again, I am telling you very simple. When you fetch this instruction at that time, do you know is this a jump instruction or not? When you fetch this instruction at that point of time, do you know, does the control unit know this is a branch instruction or not? The control unit does not know. So you can see when you fetch this instruction, you will fetch this instruction in the instruction register. The program counter will become 102. Program counter value will become 102. Program counter will basically point to the next instruction. Program counter will always point to the next instruction to be executed. So the program counter will point to this 102 address. Yes or no? Now you can see after decoding, the control unit will find out, okay, this is a jump instruction which is using relative addressing mode. So the branch target address will be this program counter value plus this offset value. So that will be 122. Okay. So then next instruction you will take from 122. From here, you will fetch the next instruction. Is this clear or not? Let me know. Please tell me, did you understand? Okay. Is this clear? Now let me tell you one more thing. Just tell me here, this branch instruction, is this which addressing mode this is using? Look at this branch instruction. Some branch instructions are given to you. Which addressing mode they are using? These are the memory addresses. These are the memory addresses. These are the actual memory addresses. So these branch instructions, look at these branch instructions. Tell me which addressing mode they are using. They are using direct addressing mode. Yes or no? They are using direct addressing mode. This is also using direct addressing mode. This is also using direct addressing mode. Why? Because you are going to the memory address directly. You are going to the memory address directly. You are jumping to this memory address directly. Okay. So very simple. So these branch instructions they are using this direct addressing mode they are using. You tell me one thing. If I want relative addressing mode, if I want relative addressing mode for branches, if I want relative addressing mode for branches, then what should I do? Tell me. I want, okay, just tell me for this branch. For this branch, you tell me this is going to 211. For this branch, you tell me, okay, what should I put here? Just tell me this point. Very simple question I'm asking. What should I put here? Okay. What should I put here? This is going to, so some offset I will put, yes or no? Can you notice that I will put the offset with respect to the program counter? So when you will fetch this instruction, what will be the program counter value? When you fetch this instruction, what will be the program counter value? Just tell me this point. When you fetch this instruction, okay, when I fetch this instruction, then what will be the program counter value? That will be 204. Okay, that will be 204, right? Yes or no? These are the addresses you can see. 200, 201, 202, 203, and so on. So 204 will be the program counter value. Okay. So now you tell me what, but I want to jump here. I want to jump here. So what value I should put here? Which value I will add to the program counter? Which value I will add? This will be your offset. What should be the offset? The offset should be 211 minus 204. That is your 7. Yes or no? Is this clear? Please tell me. Now you can see if I put 7 here, then that is your relative addressing mode. Did you understand? Yes or no? So remember, if I want relative addressing mode, then I have to put 7 here. I have to put offset 7. I have to put offset 7. Okay, this 7 I will put. So did you understand now why we call it offset? Why this is called offset? Did you understand why this is called offset? Why we call it offset? Did you understand? Because basically the branch target address that is relative to this address. Yes or no? The branch target address that is relative to the program counter. So this is just an offset, like, okay, just this distance. Offset basically that simply means distance, right? Yes or no? Offset means something like distance. It is like a distance. It is like a distance. Is this clear? Offset means it is like a distance. Okay. You tell me about the remaining. What should I write? What should I write here? Here, what should I write? This is jumping to 202. This is jumping to 202. What should I write here? This is jumping to 202. What should I write here? Remember, this is jumping to 202. First, you tell me when you fetch it. When you fetch it, then what will be the program counter value? When you fetch it, once I fetch this, then the program counter value will be 211. Correct? The program counter value that will become 211. Yes or no? So, but I want to jump to this address. I want to jump to 202. So what should be the, remember, what should I add in this 211? What should I add? What should I add so that I can get 202? In this, what should I add? In this, what should I add such that I will get 202? What I will add? I will add -9. Very good. Okay, -9. I will add. Yes or no? Is this clear? I will add -9. So here I will put -9. Okay, understood? Is this clear? So remember, here I will put -9 and here I will put 7. Here I will put 7. Here I will put -9. Okay, just tell me this one also. Just last one. What I will put here? You are jumping to 235. You are jumping to 235 from this instruction. What should I put here? Just tell me this one. So you can see when I fetch this instruction, what will be the program counter value? The program counter value will be 226. But I want to jump to 235. So what should I add? This 226, this is the program counter. Plus what should I add such that I will get 235? Such that I will get 235. That will be 9. Yes or no? So here I will put 9. Okay, is this clear? Please tell me. So these are the offsets. This 9 is the offset. This is the offset. This is also the offset. This is also the offset. These are the offsets. So I think in this diagram, in this question, you understood what is relative addressing mode. Yes or no? In this question, you carefully understood what is relative addressing mode. Please tell me yes or no. Did you understand relative addressing mode? One more thing, did you understand that in the relative addressing mode, this offset must be an unsigned value or signed value? In the relative addressing mode, there is an offset here. There is an offset here. This offset A. This offset A. This should be a signed value or unsigned value. This must be a signed value. Why? Give me one reason why this should be a signed value. Give me one reason. Because if you want to jump to some previous location, see, if you want to jump to some backward location, okay, from this location, if you want to jump to some previous location, then you need to subtract. Oh, yes or no? Basically, from this location, if you want to jump to some previous location, then you have to add a negative value. Then you have to add a negative value. Then you have to add a negative value. We are adding a negative value. Okay, we are adding a negative value. So remember this offset, this must be a signed. This must be a signed value. Okay, and signed values we store in which complement form? Signed values by default we store in a 2's complement form. Yes or no? Sign value in a 2's complement form. In 2's complement. Okay. So remember this offset, that is a signed value in 2's complement. That is a signed value in 2's complement. Is this clear? Pradeep is asking, but ALU does not know it is signed. Array, ALU knows everything. ALU knows everything. ALU knows what is the addressing mode. ALU also knows what is the addressing mode. ALU knows that this is the relative addressing mode. Okay, the control unit knows everything. Because remember, instruction set architecture, that is the property of CPU. Instruction set architecture in your CPU, what are the instructions are there? That is the property of CPU. CPU knows everything. Is this clear? CPU control unit, they know everything. They know what the addressing mode of the instruction. They know this is a signed value or unsigned value. Okay. So remember, is this clear? Please tell me. So very simple. This offset, this is a signed value in 2's complement form. Okay. This is a whenever you use relative addressing mode, whenever you use relative addressing mode, this offset, this will be a signed value in 2's complement form. Okay. So very simple. Now let's move on. Now let me tell you the application of what is the importance of this relative addressing mode. Now let me tell you that. Okay. The importance of relative addressing mode. You might be thinking why we study relative addressing mode. What is the reason why we study relative addressing mode? Let me tell you the importance, and this is very important, that basically using relative addressing mode, we can write relocatable program, relocatable codes. Okay, we can write relocatable codes. Relocatable means position independent. Okay, relocatable. When I say relocatable code, that means position independent code. They are position independent code. They are position independent code. Okay, see, let me explain. I am giving you two codes. You tell me which is one code is this as it is, which is using the direct addressing, and another code, the PC relative. Yes or no? This PC relative, this relative addressing mode. In the relative addressing mode, what were these values? This was 7, right? This was offset 7. This was -9 and this was 9. Yes or no? Okay. Very simple question I'm asking you. You just tell me. Here, which addressing mode we are using? Here, which addressing mode we are using? These are the memory addresses. These are the memory addresses. Here we are using the direct address, absolute address. Direct address means absolute address, right? Yes or no? Direct address means absolute address. So here we are using absolute addresses. Absolute addressing mode. Correct? Okay, you just tell me, let's assume this is your program, okay? And this is stored like this. After some time, another program comes, then what the operating system will do? In the operating system, this concept you have already seen, right? If another program comes, and let's assume there is no space in the main memory, then what the operating system will do? See, this is your program is in the main memory. Your program is in the main memory, right? If your program is in the main memory, this is your program. Let's assume program P1. This is in the memory, in the main memory. And let's assume you want to execute P2. You want to execute P2. There is a secondary storage. This is the, I can say, this is the backing store. Okay, this is the backing store. Now you tell me, if you want to execute P2, but let's assume in the main memory, there is no space, then what operating system will do? Let's assume you want to bring this program, but there is no space, then operating system will do what? Then operating system will put this program here and it will load P2. This is called swapping. Yes or no? This is called swapping. See, very simple point. In your memory, you have program P1. See, this is your program P1. This is your program P1. In the main memory, you have this program P1. But now you want to execute program P2. What operating system will do? This operating system will do this swapping. This swapping the operating system will do. Okay, yes or no? Means this P1 you will put in the backing store. Okay. And this P2 you will load in the main memory. After some time, again you want P1, then what will happen? After some time, let's assume P2 execution is over. Let's assume P2 execution is over. Now you want to load P1 again. Then is it necessary you will load the program at the same location? Please tell me. Like this is, let's assume 200 location. Now tell me, after some time, after P2 execution is over, P2 execution now over, then what you will do? Okay, P2 execution over. If P2 execution is over, then this P1 you will bring in the main memory. This P1 you will bring in the main memory. Is it necessary that you have to bring it at the same address, at the same previous address? Is it necessary? Please tell me. You have already studied operating system, or maybe you have some basic idea. If you did not study operating system so far, don't worry. Just tell me, use your common sense and tell me. Use your common sense and tell me. Like your Google Chrome. Okay. You are running the Google Chrome. Okay. You terminate the Google Chrome, or maybe some other program you are running. After some time, again you run the Google Chrome. Will it be loaded at the same location? No, it is not necessary, right? Okay. So this is what I'm telling you. You are running a program P1. You can easily see that if you want to run the program P2, and let's assume there is no space in the main memory, then what you will do? Then you will basically suspend this P1. Okay, you will put this in the backing store, and this P2 you will load in the main memory. After some time, P2 execution is over. Now again you will fetch this P1. Is it necessary that you fetch it at the same address? No, this is not necessary. Maybe at some other address you can fetch. Yes or no? Maybe at some other address you can fetch. Maybe at 920. Maybe at that address you can fetch. Okay, now your P1 is here. So this is called relocation, right? Yes or no? This is called relocation. Is this clear? Is this clear? This is called relocation. This is called relocation of program. We have relocated the program. Agree? We have relocated the program. Agree with me? Okay. Now you tell me. Now you will tell me. Tell me, this program, can you relocate? Okay. One more question. Once your program is in the main memory, or once your program is in the maybe hard disk, yes, just tell me one thing. Can operating system change your program? Can CPU change your program? Who can change your program? Who has the capability to change your code? Who has the capability to change your code? Either you or the compiler. Yes or no? Either the programmer, either you, okay, or the compiler. Compiler basically can adjust your program. Yes or no? This program it can adjust. Agree with me? So you or compiler, you can, only these two people can do. Operating system it cannot do. Loader it cannot do. CPU it cannot do. So tell me one thing. Now you tell me one thing. This is your program. This is your code. This is your code. Can you relocate this? Can operating system relocate this? Can operating system relocate this? Please tell me. Please tell me. Can operating system relocate this? This is my question. Can operating system relocate this code? Very simple question I'm asking. Can operating system relocate this code? Just relocate. Arey, just try. Just try, yaar. Let's relocate. Okay, just change the addresses. Let's assume operating system has relocated. Let us assume operating system has relocated. That power operating system has or not? That power operating system has or not? That you can relocate at some other address. Yes, that power operating system has. But can operating system do any changes here? Can operating system do any changes in the code? Can operating system do any changes in the code? See, this is your code. Please notice. Very common sense question I am asking. Very common sense question. This is your code. Okay, this is the code, right? This is the code. This is your code. Now I'm asking that can operating system relocate this code? Okay, let's relocate. Let's relocate. So tell me at which location should I locate? Let me relocate. I'm relocating, okay? I'm relocating. Let me relocate. I'm relocating. So tell me at which address I should relocate? Okay, let me relocate at 400. I'm relocating. Okay. At 400, you have this. At 401, you have this. Okay. Then, and tuk. You can see this you will have at, so let me relocate like this: 400, 401. Okay. 402, 402 is this. 403 is this. And then you have 410 is this. 410 is this. And then 425 is this. 425 is this. And so on. Okay. Let's assume you have relocated. Assume operating system has relocated. Has relocated. Okay. Now tell me, will your program work fine? Will your program work fine? Will your program work fine? Tell me. Now can your program work finely? Please tell me. No, no, complete mess. Very good. That is the word. Very good. Satyam, very good. Satyam, excellent. That is the word you should use. Yes, complete mess. Why? See, this instruction should jump to where? This instruction should jump. This instruction should jump to where? Just tell me. This instruction should jump to 411. Yes or no? See, this instruction should jump to 411. Should jump to 411. But where it will jump? But it will jump to where? But it will jump where? Tell me where it will jump. Just tell me where it will jump. But it will jump at 211. Did you understand? Please tell me. See, after relocating, okay, let's assume operating system has relocated. Assume operating system has relocated. Then after relocating, this instruction should jump to 411. You should jump to 411, but where it will jump? But it will jump to 211. And what you have at 211? What you have at 211? At 211, what you have? At this memory address 211, what you have? At this memory address 211, what you have? Tell me. What you have? You have moe. There is a meme nowadays. Moe. Yes or no? Is this clear? So this is the complete mess or not? Please tell me. Okay, because at 211, you can have anything rubbish you have. Yes or no? At 211, you can say, hey Ram, Jagannath, ye kya hua? There is a meme. So you can see. Is this clear? Please tell me, did you understand this? Did you clearly understand that this program is relocatable or not? Just tell me. Tell me. You are using the absolute addressing mode. You are using the absolute addressing mode. You tell me, is this program relocatable or not? Look at this program. This program, is this relocatable? This is a not relocatable. Okay, this is a non-relocatable. Can I say this is position dependent code? Can I say this is position dependent code? Can I say this is position dependent code? This is position dependent code. Dependent. This is non-relocatable code. Okay. Now something nice. Okay. Tell me one more thing. In your computer, you have all the processes. They keep relocating. Yes or no? All the processes they keep switching. You run the Google Chrome, then you run your Mozilla Firefox, then you run your some media player. Okay. All these programs in your computer, all the programs that you are running, they will keep switching. There is a context switch. Yes or no? Context switch will happen. So the relocation keeps happening or not? Tell me, for you just tell me, for you, relocation is important or not in your computer? In your computer, relocation of a program is important or not? Yes, it is important. Yes or no? Yes, it is very important. In the multi-programming environment, remember, when you have multi-programming environment, in the ready queue, you have many processes. In the ready queue, there are many processes which are ready to run. The context switch will happen. Then when the context switch happens, then remember, if your process will come back, then it can come back to some other address. Yes or no? Okay, once you suspend a process and that process will again come to the ready queue, then it can come to it can be loaded at some other memory address. So relocation is very important. You agree with me? whenever you have a multi-programming environment. Multi-programming, what that means? That means in the ready queue, there are many processes which are ready to run. Okay. So this is the multi-program environment. In the multi-program environment, relocation is very important property. Yes or no? Very important property. So you can see this is your favorite addressing mode, absolute addressing mode, and that will fail. Yes or no? That will fail to provide you relocatable code. Is this clear? Your favorite addressing mode, direct addressing mode, you are thinking this is a simple addressing mode, let's use it. Yes or no? Because it is easy, because it is easy, so let's use it. But this absolute addressing mode, this direct addressing mode, it will fail to provide you relocatable code. Agree with me? Please tell me, did you understand? Clearly, did you understand? Crystal clear understanding did you have now? Okay, you don't have to by heart anything. I'm not telling you to by heart anything. Just tell me your favorite addressing mode, this direct addressing mode, or I can say this absolute addressing mode. This is a very easy addressing mode, but this easy addressing mode will fail to provide you relocation capability. Okay, so now let's see this PC relative. This is your relative addressing mode. Yes or no? This is the relative addressing mode. Now you tell me, this program, you tell me, is this relocatable or not? My next question, is this program relocatable? Is this program relocatable? Is this program relocatable? What you will tell me? What you will tell me? You will tell me, sir, let's try to relocate. Okay, let's try to relocate. Yes or no? Is this program relocatable? Relocatable. Okay, let's relocate. Let me relocate. See, at this point of time, okay, if you relocate this, let me relocate, no problem. Okay, I'm relocating this. Okay, let's see if something bad happens or not. Will something bad happen? Will something bad happen? There will be nothing bad happen. See, everything will be good. Everything will be good. Okay, everything will be good. Now you can see, because this is relative addressing mode. So relative addressing mode, again the same thing. This now tell me, when this address will go to the fetch, when you fetch it, which program counter value will be what? When you fetch it, what will be the program counter value? Assume operating system has relocated. Assume operating system has relocated. Tell me what the program counter value? That will be 404. Okay, 404. So tell me, what will the branch target? What will the branch target? The branch target will be 404 plus this value offset 7 plus this offset 7, because you are using relative addressing mode. So that is 411. Is this correct? Should we jump to 411? Should we jump to 411? Yes. And are we jumping to 411? Yes. So remember, should jump to 411. Should jump to 411. Should jump to 411 and is jumping to 411. Yes or no? Should jump to 411 and is jumping to 411. So everything is fine or not? Is jumping to 411. Everything is good or not? Please tell me. Yes or no? Now, did you understand that relative addressing mode, that is actually giving you the relocation capability? Yes or no? So this is very important addressing mode. Relative addressing mode is used, can be used to write relocatable codes. Relocatable codes. Okay, relocatable codes. Relocatable code means position independent codes. Position independent codes. This is very important. Okay, this is very important. Actually, I have seen many students, they by heart this line they will by heart. Basically, they will not clearly understand. See, many students, they will by heart this, they will not clearly understand what is this. But yeah, they can solve questions in the GATE exam. If some question will come, they can solve that question because they have by hearted this statement. This statement they have by hearted. But did you, a Go classes student, did you clearly understand? Please tell me. And can you explain to anyone? If someone asks you direct addressing mode and relative addressing mode, what is the different, what is the important difference, can you explain? If someone asks you what is very important difference between direct addressing mode and relative addressing mode, can you explain to anyone? Can you explain to anyone? Please tell me. So this is your explanation of relative addressing mode. Now, did you find the importance of relative addressing mode? So relative addressing modes can be can be used. You can use them to write relocatable codes. Okay. Also remember, also remember, for jump instructions, for jump, or I can say, you can say branch instructions, branch instructions, for jump or branch instructions, most CPU will use this, or will use this. Okay. For jump or branch instructions, most CPU, most CPU use relative addressing mode. Okay. That we have already seen, relative addressing mode, and that we have already seen, because this is the addressing mode you should use. You should use this addressing mode if you want relocatable codes. Okay. And normally for for branch or jump instructions, this is very heavily used, I can say. Okay. This is very heavily or mainly used. Okay. So this is very popular for branch or jump instructions. Is this clear? For branch or jump instructions, the most popular addressing mode, if someone asks you for jump or branch instructions, what is the most popular addressing mode? Instructions, most relevant addressing mode, what is that? Addressing mode is a relative addressing mode. Explanation I have already given to you. Okay. Explanation I have already given to you. You can see these are the jump instructions, jump instruction, jump instruction, jump instruction. Okay. So is this program relocatable? The answer is yes. This program is relocatable. Okay. This program is relocatable. Understood? So this is the complete explanation of relative addressing mode. I think this has become your favorite now. This relative addressing mode, I think this has become your favorite now, right? So the PC value you add to the offset. This is your offset. Just add the PC value to the offset and access. This will be your effective address. Okay. So this is what we have seen. Very simple. Okay. So here this A will be your offset. And this R will be your program counter. So implicit in the instruction. So this is implicit in instruction. Okay. So very simple. Now let's move on. This is something, a result kind of thing. Actually, one thing is very important, that remember, this displacement is with respect to the current instruction or the next instruction. The displacement, please tell me in relative addressing mode, please tell me in relative addressing mode, this offset that you have is a displacement. This offset is a displacement, right? This offset is a displacement from the current instruction or from the next instruction. In the relative addressing mode, this offset is a displacement from the next instruction. Yes or no? From the next instruction. Why? From the next instruction. Why? Why? Tell me why. Because PC, because when you fetch, because when we fetch current instruction, PC will automatically be updated to the next instruction. So you can see when we fetch current instruction, current jump instruction or whatever current instruction, when we fetch current instruction, PC automatically updates, automatically increments and points to next instruction, and points to next instruction before decoding. Okay, so very simple. So this is the point. Is this clear? So that is the idea. Okay, and this is a general result that is given to you. Let's see if you can understand this. You don't have to remember this. Don't remember this. If a branching instruction is situated at address A, okay, you just tell me there is a branch instruction which is at address A. Here you have a branch instruction. There is a jump instruction which is situated at address A. and you want to jump to address B. You want to jump to address B. This address B you want to jump. You want to jump to address B. Okay. Now tell me, what will be your, what will be the displacement? Means what will be offset? What will be this offset? Assume instruction size 2 bytes. Assume instruction size is, assume instruction size is I bytes. Okay, I bytes. So tell me, what will be the answer? Assume instruction size is I bytes. Maybe you can say 2 bytes. Okay, you can take 2 bytes. For right now, you can take 2 bytes, then we will take I bytes. So tell me, if instruction size is 2 bytes, and you can see if branching instruction is situated at address A, and you need to branch to address B, you want to jump to address B. Okay, then this offset, then the offset should be what? Please tell me. Then the offset should be what? What offset should I put here? This is my question to you. What offset should I put here? So very simple. You don't have to by heart. Don't by heart. Don't by heart. Just do this. Just do this. If you fetch it, just do this. If you fetch it, what is program counter now? If you fetch it, what is program counter now? That is A plus 2, because instruction size is 2 bytes. Instruction size is 2 bytes, so that is A plus 2. Now remember, so your basically displacement will be from where to where? Your displacement will be from where to where? Your displacement, this will be your offset. Your offset will be this. Yes or no? This displacement will be your offset. Okay, so your offset will be what? Your offset will be B minus A minus 2. Is this clear? B minus A minus 2. Okay, understood? I can say B minus A minus 2. Let me know, is this clear or not? Very simple. Okay. Clear? So quite easy. And will it work if you go in the negative direction? If you go in the other direction, like maybe if you go in this other direction, maybe this B is here, will it work? Will this same formula work if B is here? Like you want to jump here. Will the same formula work? Will the same formula work? Now you can see if you fetch it, the program counter will have value A plus 2. Now the displacement, now the offset should be what? Now the offset should be A plus 2 minus B. So I can say just negative of B minus A minus 2. Okay, yes or no? It will, the same formula will work. The same formula will work, but negative, right? Yes or no? Is this clear? Actually, this should be the, sorry. The same formula will work. Okay, because we have to add a negative value. We have to add a negative value. The same formula will work. Okay, the same formula, because this will ultimately give you a negative value. We have to add this negative offset. Yes or no? This offset will be this. Offset will be this. Because remember, offset will always be B minus this. Okay, because negative value we will add. In this situation, we will add a negative value. Offset will be a negative value. In this situation, offset negative value. In this situation, offset negative value. Is this clear? So remember, this will be correct. So the same thing will work. This B minus A minus 2. And now give me the generalization. If you have I bytes, if instruction size is I bytes, whether you take this here or whether you take this here does not matter. Okay, does not matter. Remember, if your B is here, then also it will be fine. In both cases, whether you have this or whether you have this, in both cases, tell me what will be the answer. So your offset value, that will be B minus A minus I. Clear? If your instruction size is I bytes, then B minus A minus I, this is the offset. Understood? Please tell me. So this is your result. Okay, this is the conclusion. This is the conclusion. This formula will work if you have instruction size 2 bytes. If you have instruction size 2 bytes. Okay. So quite easy. Okay. So I hope you understood. Just one small thing, one more small thing. If you have a jump instruction here, and let's assume offset is f, offset, this offset is f, then what are the branch target? Then tell me what are the branch target address? What are the branch target address? Please tell me. Let me know. What will be the branch target address if your address is A? This is address A. Then the branch target address will be A plus I plus F. Yes or no? Okay, where instruction size is I bytes. Instruction size, that is I bytes. Okay. So this will be A plus I plus F. Yes or no? Is this clear? The branch target will be A plus I plus F. That will be your branch target. So you can see A plus I plus F. That is your answer. Okay, let's move on. So I hope you understood everything so far. This is enough for today. This is enough for this lecture. But before going, I want to solve some questions so that you don't forget all these concepts. So just tell me the answer for this question quickly. A PC relative branch address you are using, a PC relative, a PC relative mode branch instruction you have. Okay, PC relative addressing mode you are using, branch instruction you have, which is 3 bytes. This instruction has 3 bytes long. The address of instruction in the decimal is the address of instruction in the decimal that is given to you, that is 256028 in the decimal. Determine the branch target address if the signed displacement, this is your offset, if the signed displacement is -31. So tell me what will be the answer. Very simple. Your instruction you have here, you have a jump instruction here, there is a jump instruction here. Okay, and the branch offset, that is 31 -31. Okay, you can see in the instruction, this is a -31, this is -31, and the address in the decimal, that is 256028. Now the question is asking branch target address. So what that will be? Branch target address. Let me know what the branch target address. Okay, don't apply the formula. Do not apply the formula. Do not apply the formula. This is a 3 byte instruction. Do not apply the formula. Without applying the formula, you tell me. Apply the concept. So you can see, if you apply the formula, what answer will be? If you apply the formula, the answer will be, this is your A. Okay, this is your F. If you apply the formula, if you apply the formula, this is F, then you can see this is I, this is I. So if you apply the formula, it will be A plus F plus I, A plus I plus F. Correct? Okay, so that will be, what that will be? That will be 256028 plus I, that is 3 minus 31. What is this value? Can anyone tell me? What is this value? Basically 28 you are adding. 28 you are subtracting. So that will be 256002566000, right? Yes or no? 256000. So this is the formula you are applying. If you apply the formula, this is the answer you will get. This is the formula. But without the formula, what will happen? In the GATE exam, you will forget the formula. I promise you, you will forget the formula. So don't apply the formula. Conceptually, what will happen? How you will solve it conceptually? See, when you fetch it, what will be the program counter value? When you fetch it, what will be the program counter value? What will be the program counter value when you fetch it? Program counter will point to the next instruction. This instruction is 3 byte. This instruction is 3 bytes. Program counter will point to the next instruction. So the program counter will have 256031. Correct? Okay. This is the program counter will have. Now your branch target address will be program counter value plus this offset. plus this offset. So it will be 256031 plus offset. Offset is minus 31. So that is your answer. Okay. So like this, you can solve it. Is this clear? Very simple. So that is enough. So this is enough for today. In this lecture, whatever we have seen, whatever concept we have seen, all the concepts, did you understand? Please tell me. And this PC relative addressing mode, did you clearly understand? PC relative addressing mode, what is this addressing mode? And what are the applications of this addressing mode? Why this addressing mode is so popular and why it is so useful? Clearly, did you understand? Can you explain this PC relative addressing mode and its applications to anyone? That is important. So remember, what is the application of PC relative addressing mode? Relative addressing mode is used to write position independent codes. Okay, you can write relocatable codes, you can write using PC relative addressing mode. Okay, so remember, relative addressing mode, using the relative addressing mode, remember, you can write position independent codes, you can write relocatable codes. Okay, so that is what we have seen in this lecture. Okay, thank you everyone. In the next lecture, we will study the remaining addressing modes. There is base register addressing mode is remaining. Okay, so that also we will study. And also we will study the concept of absolute address code, absolute code, and relocatable code. Okay, we will again revisit relocatable code. What is relocatable code? And this base register addressing mode is remaining. Remember, one addressing mode is remaining, that is base register addressing mode. And let me tell you, the most important addressing mode for writing relocatable code, that is base register addressing mode. Okay, so tomorrow we will study base register addressing mode, and I will tell you the applications of base register addressing mode. You will see that base register addressing mode can be used to write position independent code, or I can say relocatable codes. So for writing relocatable codes, how many addressing modes you have? For writing, if you want to write relocatable codes, you have two addressing modes. One is relative addressing mode, another is base register addressing mode. This base register addressing mode we will study in the next lecture. Okay, thank you everyone. See you tomorrow. Thank you.